Okay. Good evening, everybody. Welcome to another edition of Final Countdown. This is week 4, day number 2. So let's get into work. So we have already discussed 20 MCQs, one structured essay, one essay, one structured, one essay in 2003 paper. Right. Moving on. Right. Have a look at this. The second input of the gate shown in the diagram are connected to binary 1. Second input is connected to binary number 1. Of the gates, performance are identical only in. Now these are not gate. There. The second input is connected to 1. So the first input can be 0. So let's say this is 0. Not gate means 1. If this is 1, this is going to be 0. Right. 1 is going to be 0. Okay, no? Here no gate. 0, 1, no gate means 1. 1, 1 means OR gate means again 1. So 0, 1 is also 1, 1, 1 is also 1. Right. There is a AND gate. 0, 1 is 0. 1, 1 is 1. So, looking at this, these slightly same, but the relationships are different. Right. Here it's a NAND gate. 0, 0 should be 1. 1, 1 should be 0. 1, 1 should be 0. So, these two are identical. Right. Here there is a NOR gate. 0, 1 should be 0. 1, 1 should be also 0. So what are the identical outputs? You can see identical outputs are obtained from these two. P and R. P and R. Again look. Output binary is given. Output binary is given. Here the gate is the NOR gate. There is a small difference in the original. P, this is Q. P, Q. P, Q. R, S and T. Please change that. So P and T you have the same answer, correct answer is answer number 5. P and T we have the same answer is answer number 5. There is a small change in the original. No? Small change. Right. Okay, no? Small change in the original. Whatever said and done, these two only are correct. That's all. Whatever the names you don't care, only these two are correct. Okay. Right. Okay. In the circuit shown, charges on the 1 microfarad and 5 microfarad are. Right. Remember when you do these calculations, it's at steady state. Steady state means across the capacitor no current is passing through. There, no current is passing through. So here if you take, across this no current will pass through. Across this no current will pass through, here you go. Current will go through this. So if you apply Kirchhoff law, for this complete loop, if you apply Kirchhoff law for this complete loop, I will name it A, B, C, D. So A, B, C, D loop. A, B, C, D, A loop. Sum of EMF equals sum of potential differences. Here minus 15, here plus 50. Minus to plus, plus. Minus to plus, plus. Loop direction, current direction same. So 5 and 10, 15. 15I, current is equal to 1 ampere. Okay, found. Right. Now we can consider this loop. XY are put here. XY are put here. We put a different loop region. There you go. Consider AXYDA loop. Sum of EMF equals sum of potential differences. Very simple. Minus to plus positive. This loop, so here no resistor. Here also, even though the resistor is there, no current. So the voltage across will be the voltage of the capacitor. Voltage across the capacitor. So 15 volt will across the capacitor. So if I apply Q is equal to CV, 1 microfarad 15 microcoulomb across 1 microfarad. 15 microcoulomb across 1 microfarad. 1 microfarad. Right. Now let's apply here. Apply loop here. If you apply B is a PCB loop. Sum of EMF equals sum of potential differences. Do I have any battery here? No battery. Here loop direction, current direction opposite. So minus I times 10 plus. So this is 0 means minus and plus should add. Voltage across the capacitor. Current is 1 ampere. So voltage across the capacitor is going to be 10 volt. Now apply Q is equal to CV across 5 microfarad. 5 times 10, you have 50 microcoulomb. 50 microcoulomb. So 1 microfarad, 15, second one, 50 microcoulomb. The correct answer is answer number 2. Correct answer is answer number 2. You can see what we have done. We have applied Kirchhoff law for the bigger loop and we applied Kirchhoff law for the small loop. The secret is across the capacitor only at steady state we can apply. At steady state no current will pass through. There. At steady state no current will pass through. So if you apply Kirchhoff law here, we can find the total current. Apply Kirchhoff law here, this 15 means here also 15. Apply Kirchhoff law here, this voltage and that voltage will be the same. Why? Sum of them should be 0 means if this is minus, the other one should be plus. So voltage across the capacitor is 10 volt. Substitute here, we can get 50 microcoulomb. 50 microcoulomb. Right, that is one sentence there. Across the capacitor at steady state, no current will pass through. Across the capacitor at steady state, no current will pass through. Once you need it, quickly write down. Right now, okay, moving on. Figure shows 3 conducting spheres of radii R1, R2 and R3. Of radii R1, R2 and R3. R3 is larger than R2 is larger than R1. Each carry a current Q. If the electric field intensity is at points A, B, C at a distance R from center R, What can you say? Now each of them have a charge q. Each of them have a charge q, right? From your basic special note, what can you do? Take all the charges, keep it at the center like a point charge, fine. So like a point charge, if you find it, q divided by 4 pi epsilon naught r squared. Take all the charges, keep it at the center like a point charge, fine. So like a point charge, q divided by 4 pi epsilon naught r squared. Take all charges, keep it at the center like a point charge, fine. So like a point charge, if you find it, q divided by 4 pi epsilon naught r squared. All the electric field strength magnitudes are the same. All the electric field strength magnitudes are the same. So your answer here is answer number 2. Answer is answer number 2, all are equal. Okay? Right. Moving on. The battery in a given circuit has negligible internal resistance. The potential variation around the circuit when the switch S is open is best represented by switch is open. Switch is open means here grounded, here 0 volt, here 0 volt. Don't forget these are non-resistant 0 volt. If that is 0 volt, here plus minus of higher. Higher potential means 0 plus V0. Here V0. Up to here V0. Here also 0 volt. Look at this carefully. Yeah? Is current passing through? No current is passing through. Open circuit. If current is not passing through, potential difference is 0. Potential difference is 0 means here also V0, here also V0. Right? So these are your voltage drop rates. Again look, here 0 volt, negative to positive means you are carrying a step up, V0, 0 plus V0. Here V0 means here V0, no current is passing through, open switch. So potential difference is 0 means here also V0, here also V0. So if you carefully draw it, or if you carefully write it, A potential is V0, B potential is V0, C potential is V0, D potential is V0, E and F is going to be 0. Correct answer is answer number 3. Correct answer is answer number 3. Okay, no? Correct answer is answer number 3. Okay? Right. The defective eye of a person has a near point of 0.5 meters. So 0.5 meters means 50 centimeters, right? So you can see he is far-sighted. The magnitude of the power of the lens that the person has to use to bring the near point to 25, right? So you will need a convex lens to keep the object at 0.25 meters. Image is formed where the eye can see. Image is formed at 0.5 meters. Image from the lens is object for the eye. Simplify this. 1 over B minus 1 over U equals 1 over F. Here, object distance is 0.25. Image distance is 0.5. Focal length F. Common denominator 0.5. 1 minus to get 0.5 multiplied by 2. From this you get minus 1 over 0.5, 1 over F. Okay. Take the minus there, minus 1 over F. Minus 1 over F is power. 10 divided by 0.5, 10 divided by 5. Simplify this. 1 divided by 0.5 is 10 divided by 5. Power is equal to plus 2 diopter. Plus 2 diopter. Plus 2 diopter means answer is answer number 1. Answer is answer number 1. Right there. Since the near point is at 50 centimeters from the eye. Since the near point is at 50 centimeters from the eye. This is a far-sighted person. This is a far-sighted person. This is a far-sighted person. Therefore, we must use a convex lens. Therefore, we must use a convex lens. Therefore, we must use a convex lens. So that when the object is placed at 0.25 meters, when the object is placed at 0.25 meters, the image is formed at 0.5 meters. The image is formed at 0.5 meters, which the eye can see. Which the eye can see. Right. Consider the following statements. A. If the kinetic energy of a particle is constant, kinetic energy is constant with time, momentum should also be constant. Famous equation P squared equal to me. Kinetic energy is a scalar. Momentum is a vector. Just because the kinetic energy is constant doesn't mean the momentum or the vector will be constant, because vector will change if the direction changes. So statement A is wrong. Write the small sentence. Write the small sentence. Just because the kinetic energy is constant, the momentum cannot be constant because momentum is a vector quantity. Momentum is a vector quantity. Momentum is a vector quantity. And kinetic energy is a scalar quantity. Kinetic energy is a scalar quantity. If the direction changes, the momentum will also change. Right. If the momentum is constant, then the kinetic energy is constant. So momentum is constant means direction is not changing. Then guaranteed kinetic energy is constant, V is correct. Right there. If the momentum is constant, this means the direction is constant. Therefore, we can say the kinetic energy can be constant. Okay? If the momentum of the particle varies linearly with time, so momentum varies linearly, so P squared means proportional to T squared. But all of you all know P square is proportional to E. Therefore, kinetic energy is also proportional to T square. Right. If momentum of the particle varies linearly with time, kinetic energy should also vary linearly with time. Wrong. It's varying non-linearly with time. C is also wrong. Only B is correct. Answer number 2. Only B is correct. Answer number 2. Right. Moving on. A beaker contains two immiscible liquids, two different liquids, having densities D1 and D2. Three spheres ABC made of materials of densities dA, dB, dC respectively are released from the bottom of the beaker. So they are given you conditions. Which one is larger? DC is larger. Which one is smaller? D1 is smaller. Right. Okay. Released from the bottom. Right. So which statement is correct? Density of D is very much larger than D1, larger than D2. So the question is, sphere will reach surface xy and come to rest. Can the C go to the surface? Look at the densities and tell me. Look at the densities and tell me. So here looking at this, DC is large. Large density, can it go to the surface? Well, simple, the answer is no. The answer C cannot go to the surface, right? All spheres will reach the surface xy, wrong. C will not reach. So this is wrong means this is wrong. None of the spheres will move up. That's also wrong. Here, dB is lesser than d2. So dB will go up for sure. dA is lesser than d2. A will also go up for sure. But it's greater than d1. So maybe partially immersed or whatever, but it will go up. So here, none of the spheres will go up, that's also wrong. Spheres A and B will reach the surface xy and come to rest. Not to surface xy. Why? Why not to surface xy? Because A and B are greater than d1. So it can't go up, it will be below, maybe in this interface. But not to the surface xy. So from this we can say, this is wrong. So only correct statement will be answer number 5. Only correct statement will be answer number 5, right there. A and B will move up maybe to the common interface. A and B will move up to the common interface. And at different volumes it will submerge in both the liquids. And at different volumes it will submerge in both the liquids. And at different volumes it will submerge in both the liquids. But C will never move upwards. But C will never move upwards. Okay, now? Right. Next one. Figure shows underground cave, two small openings, A and B. So what can you say when the streamlines get closer at the top? When they get closer at the top, speed will what? Increase. Speed increases, pressure reduces. Here speed is less, pressure is large. So pressure at A is larger than pressure at B. So air will travel from A and B through the burrow. Air will travel from A and B through the burrow. So velocity at B is larger than velocity at A. Pressure at A is larger than pressure at B. From A to B it will pass through. Answer is answer number 2. Answer is answer number 2. Whose theorem is this? Bernoulli's theorem. Bernoulli's theorem. Bernoulli's equation. Bernoulli's equation. Right. Okay. Next one. A toy connected to a fixed point of an elastic string as shown in the figure travels in a horizontal circle of radius 2r. The initial unstretched length of the elastic string is r. So unstretched length is r. This is 2r. So who is giving centripetal force? Elastic force. Hooke's law, elastic force is k times x is extension. Extension is 2r minus r, that's going to be r. F1 is equal to kr. F1 is equal to kr. Period of rotation is t. So omega is equal to 2 pi divided by t. Centripetal force equals mass into centripetal acceleration. Who is providing centripetal force? F1. Centripetal acceleration omega squared, radius is 2r. Simplify this carefully. F1 is kr. Omega is 2 pi divided by t whole thing square 2r. Simplify this. Kr equals m 4 pi square t square 2r. Equation number 1. Equation number 1. Right. Next category. The car is speeded up until the radius is 3r. Now radius is 3r. So what's the stretch length? 3r minus r, 2r. So extension is 1. So now we can apply here. Again, who is applying centripetal force? Centripetal force is given by the spring force. K times 3r minus r. Mass omega 1 squared into radius is 3r. K times 2r. M omega 1 is 2 pi divided by T1 whole thing squared 3r. 2rk equals M 4 pi squared over T1 squared 3r, equation number 2. Divide the first equation by the second equation. Kr is equal to M 4 pi squared T squared 2r divided by 2rk M 4 pi squared T1 squared 3r. Look at the board carefully. Kr cancel off. M cancel off. 4 pi squared cancel off. R cancel off. Simplify this. Half here. T1 squared goes on top. T1 squared over T squared. 3 is here. 2 is here. Cross multiply. T1 squared is 3 over 4 T squared. From this you can find T1. T1 equal root 3 divided by 2 into T. Root 3 divided by 2 into T. Root 3 divided by 2 into T. Now I'll check the original answers. I think there is a mistake on the board. Yes, answer number 4. This answer number 4 is root 3 divided by 2 into T. So this answer printed is wrong. This is your correct answer. That is the correct answer I get. Okay? That is the correct answer I get. Right, carefully write this down. Let's write. The elastic force will give us the required centripetal force. The elastic force will give us the required centripetal force. The elastic force will give us the required centripetal force. Once you need it, write it down for this quickly. Okay. Right. Now when the length becomes 3r, right there. When the length becomes 3r, when the length becomes 3r, so 3r means extension is given 3r minus r. Radius will be 3r. Simplify, divide one by the other, you get the answer. Here root 3 over 2 times here. Okay. Right, no? Okay. Moving on. Two uniform rods AB. Now you can see it's almost at the same dimensions, but maybe different materials. So L here, L here. L here, L here. Rotational kinetic energies are the same. So what's the theory? L squared equal to IE. L squared equal to IE. Rotational kinetic energies are the same means angular momentum of A divided by angular momentum of B, moment of inertia of A divided by moment of inertia of B. What's the moment of inertia of A? Look at the board now. 1 over 12 mass is M. Sorry, mass is MA L square. 1 over 12 mass is B L square. 1 over 12 L square cancel off. 1 over 12 L square cancel off means we have LA squared over LB square, that is equal to MA over MB. Same dimensions means volume is same. Volume into density dA is mass. Volume into density dB. There you go. VV cancel off. VV cancel off. Simplify the relationship. Simplify the relationship. LA divided by LB, that is equal to dA divided by dB, whole thing square root. That means dA divided by dB square root, answer number 4. Answer number 4. Right? Answer number 4. So you can easily say here, what no? Angular momentum square is 2IE, just like P square equal to me. For P we have angular momentum, 2 is there. For mass we have moment of inertia. For translational kinetic energy we have rotational kinetic energy. Translational kinetic energy we have rotational kinetic energy, right? Okay. Look at the board. A string is stretched between two fixed supports. String is stretched between two fixed supports. It is observed that it has two consecutive resonant frequencies at 300 and 400. Lowest resonant frequency. So stretched between means vibrations of a string. Vibrations of a string is given by n over 2L square root T over n. Now length is same, T is same, M is same. Frequency is proportional to harmonic number. Remember, harmonic number is 1, 2, 3, 4, any number. Now they are telling you here consecutive, one by one close by the other. Difference is 1. So 300 if the harmonic number is n, 400 the harmonic number is n plus 1. Now we can't say first harmonic. So consecutive means close by, one next to the other. So harmonic number is n means this harmonic number what? N plus 1. Simplify the relationship. 400 divided by 300, that is n plus 1 divided by n. 20, 20 cross multiply. 4n equals 3n plus 3. That means n is equal to 3, right? 300 means third harmonic. 300 means third harmonic. 300 means third harmonic. That means fundamental frequency means 100 hertz. Fundamental frequency means 100 hertz. Correct answer, answer number 2. Correct answer, answer number 2. Right there. Right there. The frequency is proportional to the harmonic number. The frequency is proportional to the harmonic number. Consecutive frequencies mean consecutive harmonic numbers. Consecutive frequency means consecutive harmonic numbers. Consecutive harmonic numbers. Clear? Clear? From the consecutiveness, you can get the relationship. Okay? Right. So here 300 proportional to n, here 400 proportional to n plus 1. Divide one by the other, you get the relationship. From there, you have this particular answer. Okay? Right. Next one. Which of the following is a possible path of the ray? Now, if it comes from 90, I know the ray should go. If it comes at 90, it should go straight. So this is not possible. Okay. Here, prism angle. Here 90 minus A, this can be A. This can be greater than critical angle, but light ray coming straight here, that is possible, impossible. Right. Here, towards, it should go down, not up, 3 no. This one. It can come here. It can't go along the surface. This is possible. Fifth one is possible. Fifth one is absolutely possible. Okay? Right. Moving on. An astronomical telescope is in normal adjustment. What do you mean by normal adjustment? Object at infinity, image is also formed at infinity. The diameter of the incident light beam falling on the objective is d. So here you go. Objective lens has bigger diameter. Light rays are coming from far away. Bigger the diameter, better. Then, so here, right. Okay. Now what? Telescope magnification is simple. What's the diameter of the emerging beam? That means diameter of the eyepiece. Diameter of the eyepiece. Right. Have a look. So here you can say this is focal length of objective. This is focal length of eyepiece. Focal length of eyepiece. If this angle is theta, this angle is theta. Tan theta is equal to opposite over the sun, half this length. D divided by 2 over F naught. Tan theta is opposite over the sun. DE divided by 2 over FE. What can you say here? 2 cancel off. D over F naught equals DE over FE. Simplify this carefully. F naught over Fe is dE. F naught over Fe is magnification dE. Diameter of the eyepiece d over m. Diameter of the eyepiece d over m. D over m means answer number 1. D over m means answer number 1. Okay. Right. Can we write it down? That's right. Using geometry, we can find the relationship between the diameter of the objective and the eyepiece. We can find the relationship between the diameter of the objective and the eyepiece. Diameter of the objective and the eyepiece. Diameter of the objective and the eyepiece with the focal lengths. With the focal lengths. With the focal lengths. Okay. Right. Write down quickly the ones who need it. Right. Read. Two strings A and B have equal lengths and equal cross-sectional areas but different densities are connected together. The composite string is stretched across two fixed walls. Two pulses simultaneously sent along A and B from both ends. So the densities are different means velocities are different. So velocity equation square root T over simple M. Simple M is A rho. Tension is same, area is same. Velocity is inversely proportional to square root of density. So here velocities will be different, right? Found that they pass along center O at times TA and TB. Diameters or densities are given. Then what can you say? Look at the board now. Here velocity at A inversely proportional to density at A. Velocity at B inversely proportional to density at B. VA divided by VB is dB divided by dA. Now here dB divided by dA is 1 over 4. 1 over 4 square root means VA is equal to VB divided by 2. So VB is faster, VB divided by 2. Right. What are they asking you? What can you say about the times? Time taken by A is distance divided by speed. Time taken by B is distance divided by speed. Divide one by the other, TA divided by TB, that is VB divided by VA. VB divided by VA. Now you have found VB divided by VA. Here, VB divided by VA is 2. Substitute there. VA divided by VB is 2. So TA is equal to 2 times TB. TA is equal to 2 times TB, or you make TB the subject. TB is equal to half times TA. TB is equal to half times TA. Correct answer, answer number 2. Correct answer, answer number 2. Correct answer, answer number 2. Right now? So again look, when the densities are different, the speed of the wave in the string will also be different. Speed is different means time taken will be different. Once you need it, write it down. Okay, right. So once you know the ratio of the velocities, you can find a relationship for the time. So you can see it's not difficult. There, these are not difficult. Actually, you can see. See, I'm also working with you all. I'm using minimum space to solve. Only when there is some additional theory to teach, yes. Essay questions, yes. But MCQs you can see in a given small space and solving. So you should also practice that. Huh? That's why I given a small space for you all to work in that space. A train moving along a straight track at a velocity 30 meters per second emits a sound of frequency 600 Hz. If the speed of sound in air is 330, the wavelength of the sound propagating forward along the track will be. So, source is there, making a sound of frequency 600 Hz, traveling along the track with a velocity 30. Assume there is an observer here in front. So sound travels from the source to the observer with a velocity v, velocity of sound. Right. Frequency heard here is f dash. Frequency heard there is f dash. Right. F dash is velocity of sound with respect to observer v. Velocity of sound with respect to source v minus 30 into actual frequency. Don't substitute. Now I apply v equal f lambda with respect to observer. Because sound is heard by observer. Velocity of sound with respect to observer is f. Frequency of sound heard by the observer is f dash. F dash is vf divided by v minus 30 into lambda. Lambda is the wavelength he will hear. From this you can find, I can cancel v and v off. From here you can say lambda is equal v minus 30 divided by f. V minus 30 divided by f. Do the simplification. 330 minus 30 divided by 600. 300 divided by 600 is 0.5 meters. 0.5 meters. 0.5 meters means 50 centimeter. 0.5 meters means 50 centimeters. Answer is answer number 4. Answer is answer number 4. Right there. When we find the wavelength, when we find the apparent wavelength, we must consider V equal f lambda with respect to the observer. V equal f lambda with respect to the observer. V equal f lambda with respect to the observer. Okay. V equal f lambda with respect to the observer. Right. Okay. Right. Carefully write it down once you need it. It's very simple and direct. Right. Next one. Net flux through the closed surfaces can be reversed. So flux means sum of charges divided by epsilon naught. Sum of charges means 7q minus 5q, that's going to be 2q over epsilon naught. Flux is going to be positive. Reversing the flux means making the flux negative. So what if I make 4q1, 3q, 4q, 3q, 1q, 4q, 4q minus 5q minus 1q. This is the correct one. Changing 4q to 1q. Changing 4q to 1q. Okay? 4q to 1q. Right. Next one. Two identical thin metal cans A and B containing equal amounts of water and a heater using identical domestic electrical heaters. Can A and B are kept on a large metal block and wooden block. These are metal, these wood. So directly you should know some conduction issue is only here. Tell me now, if there is metal here, heat will not quickly conduct. Here if there is wood, heat will not quickly conduct. So this temperature will be higher than that temperature. Right. Common sense is there. Let's see how it works. Right. Out of this, what can you say? Out of this, what can you say? Can the temperature of A be greater than B? No. Can the temperature of A reach boiling point? Actually, no. Never. Okay. Can both of them be same? No. Can both of them be same? No. This is the most possible answer. B can reach boiling, but A will never reach boiling. But whatever heat that comes in, heat will be conducted. Here, heat is not conducted. Good. So, correct answer is answer number 3. Correct answer is answer number 3. Right there. When heat is supplied by the heater, water and the can will absorb the heat. 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 But if there is a metal, heat is conducted through the metal. When there is a metal, heat is conducted through the metal. So the container kept on top of metal cannot reach. So the container kept on top of metal cannot reach. (100°C). Cannot reach 100°C. But the container connected to wood can reach 100°C. But the container connected to wood can reach 100°C because wood is a very weak thermal conductor. Wood is a very weak thermal conductor. Wood is a very weak thermal conductor. Right. Moving on. Consider the following statements carefully. Constant volume gas thermometer is not suitable for measuring rapidly changing temperatures because it's not an accurate thermometer. Yes, it is not suitable to measure rapidly changing, but it is the most accurate thermometer. So why can't you use it? The bulb should be fully submerged. Bulb should be fully submerged in the liquid. So rapidly, quick, and it will take some time for the temperature of the water and the temperature of the gas inside the bulb to reach thermal equilibrium. So rapidly changing temperatures you can't measure using gas thermometers. But gas thermometers are the most accurate thermometers. Put a small star there, write this. Gas thermometers are the most accurate thermometers. Gas thermometers are the most accurate thermometers. Gas thermometers are the most accurate thermometers because they are used to calibrate other thermometers. They are used to calibrate other thermometers. They are used to calibrate other thermometers, but they cannot measure rapidly changing temperatures. Rapidly changing temperatures. Because it will take some time. Because it will take some time for thermal equilibrium to be reached. It will take some time for thermal equilibrium to be reached. It will take some time for thermal equilibrium to be reached. Right. Next one. Thermocouple. So statement A is wrong. Thermocouple is suitable for measuring rapidly changing temperatures because heat capacity is large. Because heat capacity is large. Remember, if heat capacity is large, the metal will absorb a lot of heat from the object. If metal is absorbing a lot of heat from the object, what happens is the object temperature will reduce. Think logically here. If the heat capacity is very large, the thermocouple will absorb a lot of energy from the object. So object temperature will reduce. Can you measure it accurately? No, you can't measure. Is it clear? So thermocouple is suitable to measure rapidly changing temperatures. Why? Because point temperatures can be quickly measured. Right there. A thermocouple is suitable. A thermocouple is suitable to measure rapidly changing temperatures because point temperatures can be easily measured and the heat capacity of the metal is low. Heat capacity is low. So it will be absorbing a little amount of heat from the object. So it will be absorbing a little amount of heat from the object. If the heat capacity is large, it will absorb a large amount of heat. If the heat capacity is large, it will absorb a large amount of heat. It will absorb a large amount of heat. It will absorb a large amount of heat. And the temperature of the and the temperature of the object will reduce. And the temperature of the object will reduce. So these also wrong. C. Mercury glass thermometer is not suitable to measuring rapidly changing temperatures because the heat capacity is very small. Wrong. I mean, this part is correct, but the reason is wrong. Because in a thermometer, the bulb should be fully submerged in the liquid. And it will take some time, for the bulb to reach thermal equilibrium. Bulb to reach thermal equilibrium. Okay. And it doesn't have a low heat capacity. Why? You are using mercury. Mercury has high heat capacity. Okay. So statement A, B, C all are wrong. Correct answer is answer number 5. Right there. Mercury in glass thermometers cannot measure rapidly changing temperatures. Cannot measure rapidly changing temperatures because the bulb should be fully submerged in the liquid and due to its sensitivity, it will take some time to give us the reading. But actually, if you use a mercury thermometer, quickly it will change. Your body temperature is quickly changing. So you can measure, but heat capacity is not low. Heat capacity is high. Like that. Also, the temperature of a human body can be measured using a mercury glass thermometer. The temperature of a human body can be measured using mercury glass thermometer. But the heat capacity of mercury is large. So this part is wrong. So no. Okay, no? Right. Question number 19. Consider the following statements made about space just above a small block of ice placed in still air, where room temperature and relative humidity are 30% and 80% respectively. Now they are asking you just above the space, just above the space. Okay, just above the space. Right. So RH variation with time, AH variation with time. Right. So room temperature and relative humidity 80% is there. Absolute humidity in the space above. Read the question carefully. Absolute humidity in the space above. The ice block is higher than the absolute humidity of air far away. Interesting concept. Absolute humidity of air just above the ice block is higher than the absolute humidity of the air away from the ice block. So ice block is kept in a room. Is telling water vapor here is very large compared to water vapor away. What do you think? What do you think? If you take ice, the temperature of ice is actually what? 0 degrees Celsius. If temperature of ice is 0 degrees Celsius, room temperature 30, dew point is going to be approximately around 25, let's say. Ice is 0 means around ice, what can you say? Saturation has taken place. Here, saturation has taken place. Saturation near the ice block has taken place. Saturation near the ice block has taken place means RH is actually 100%. RH is actually 100%. Then RH is actually 100%. Right. Okay. So again read absolute humidity of air in space just above the ice block is higher than the absolute humidity of air far away from the ice block. Far away from the ice block. Where? Far away from the ice block. Now RH is maximum. Right? So condensation takes place. RH is going to be maximum. RH is going to be maximum means AH will reduce. AH will reduce. Absolute humidity will reduce. Okay? Remember the curve, right? Okay. Relative humidity. So absolute humidity near the ice block will keep reducing. Statement A is wrong. Right? So ice temperature 0, that's less than the dew point. Less than the dew point means condensation takes place. Condensation takes place means RH is 100%. RH is 100% means absolute humidity will keep on reducing. You remember the graph, the temperature graph? Keep on reducing. Right. B. Relative humidity of air in the space just above the ice is higher than the relative humidity of air far away from the block. That's correct. Just near the ice, saturation has already taken place. RH is 100%. Third one. Air in the space just above the ice block is drier than the air away from the ice block. Drier than the air away from the ice block. Again look. Air in the space just above the ice block. Read the notification carefully. Air just above the ice block is more drier than the air away. What do you mean by drier? What do you mean by drier? Here. If saturation occurs, it's going to be wet. If saturation occurs, it's going to be wet. Okay. And when absolute humidity reduces, when AH reduces, there, AH keeps on reducing. When the AC is being put, AH absolute humidity keeps on reducing. Are you feeling wetter or drier? Drier. Air in the space just above the ice block is drier than the air block away. C correct. Again think. Let's say AC removes water vapor. When removing water vapor, AH will reduce, absolute humidity reduces. AH keeps on reducing. Are you feeling better or drier? You're feeling dry. So dry means AH keeps on reducing. C correct. So your answer here B and C correct. Answer here B and C correct means answer number 3. Answer here B and C correct means answer number 3. Okay. Right. That is one sentence then. I think this might be important for you. That is one sentence. The temperature above the ice block is close to 0 degrees Celsius. Temperature above the ice block is close to 0 degrees Celsius. This means it's below the dew point temperature. Temperature above the ice block is below 0 degrees Celsius. This means it is lower than the dew point temperature. This means it is lower than the dew point temperature. This means it is lower than the dew point temperature. If it is lower than the dew point temperature, saturation will take place. Saturation will take place. That means absolute humidity is 100%. Absolute humidity is 100%. Keep writing. Sorry, relative humidity is 100%. My mistake. Relative humidity is 100%. This means absolute humidity will keep on reducing. Which means absolute humidity will keep on reducing. Which means it will get drier. Absolute humidity will keep on reducing, which means it will get drier. Okay. So correct statement is B and C. Right. Question number 20. Two blocks A and B initially at 80 degrees Celsius So these at 80 degrees Celsius, these at 30 degrees Celsius, right? Enclosure is insulated from the outside. Which of the following statement is correct prior to the system being reaching equilibrium? So reaching equilibrium means both of them will reach a middle temperature. So what will happen? Heat by A is given. Heat is absorbed by B and the room. So temperature of the room will also increase, B will also what? Reduce, increase. A will reduce. So I think it's a very simple connection. So looking at this, what can you say? Temperature of A will reduce, B and the room will increase. By insulated, no heat is going out. So statement 1 is wrong. Temperature remains unchanged, wrong. Enclosure remains at room temperature, but A and B will change, wrong. Enclosure temperature also increases. Temperature of the enclosure and the block B increases. Due to radiation heat transfer, A will reduce temperature, B and the room will absorb heat. A will give out heat, B and room will absorb heat. A will give out heat, B and the room will absorb heat. Causing the temperature of B and the room to increase. Okay, right. Structured essay, dew point experiment number 29. Right. You are asked to determine the dew point inside the laboratory using a polished calorimeter. What is the experimental procedure that you would follow in this experiment to form dew on the calorimeter surface? So what you do is you take two polished calorimeters. Fill it with water about 2/3 or half. Take ice cubes. What do you do? Insert one ice cube at a time and stir. Insert one ice cube at a time and stir. So that's the experimental procedure. Right there. We take two identical polished calorimeters, fill water up to the same level, and we insert one ice cube at a time to one calorimeter. On one calorimeter. Right. Next one. Two temperature readings are to be taken in the experiment. What are they? Now going back. So what will happen? Initially, what will happen? The brightness of the calorimeter will initially disappear. When the brightness of the calorimeter disappears, we stop inserting ice and measure the temperature. Right there. When the brightness of the calorimeter surface when the brightness of the calorimeter server starts to disappear, we stop inserting ice and measure the temperature. We stop inserting ice and measure the temperature. We stop inserting ice and measure the temperature. So you can write here, when the brightness of the calorimeter starts to disappear. We measure temperature of water. We measure temperature of water. Right. Next one, what we do? We stop inserting ice and keep on stirring until the brightness reappears. So you want to write here, when the brightness of the calorimeter starts to disappear. Right. Next one you can write, we stop adding ice. And we keep stirring. Until the brightness just reappears. We measure the temperature of water. Okay, no? So when the brightness first disappears, when the brightness first reappears. Okay? Right. Okay, no? In this experiment, water is stirred to achieve uniform temperature throughout the volume of water. Why is it important? Why do you need to continuously stir to achieve this? Now, in reality, what are you going to measure? In reality, dew is formed on the outer surface. We must measure the temperature of the outer surface. But we can't measure the temperature of the outer surface. That is why we are measuring temperature of water. So, temperature of the outer surface should be equal to temperature of water. That is why we continuously stir. Right there. Actually, we need to measure the temperature of water, the temperature of the calorimeter surface. Actually, we need to measure the temperature of the calorimeter surface. But it is impossible to do this. Therefore, we continuously stir. Such that the temperature of water and the temperature of the calorimeter surface will be the same. Right now, temperature of water and temperature of the calorimeter surface will be the same. That is why we stir. Okay. If the two temperatures obtained are 23.2 and 23.6, first the dew point. Now dew point is the average. 23.2 plus 23.6 divided by 2. That's 23.4 degrees Celsius. 23.4 degrees Celsius. Right? In a certain day, room temperature 30, dew point is at 25. Right. Find the relevant formula to find the relative humidity. Again, short form. Exam day you must write the full one. SVP, saturated vapor pressure at dew point, divided by SVP, saturated vapor pressure at room temperature, multiplied by 100. SVP at dew point means $25 millimeter mercury at 30 degrees Celsius. 35 millimeter mercury multiplied by 100. 7. 500 divided by 7. 500 divided by 7 is 7, 1, 4. 71.4 RH. Relative humidity is 71.4. Right. Hence find the RH I have done there. When you blow your breath on a polished metal surface, you can observe the surface brightness will reduce. Explain the reason. Why? Exhaled air has water vapor, hot water vapor. When the water vapor touches the glass surface, sudden condensation will take place. Right there. Exhaled air has water vapor. Exhaled air has water vapor. When this water vapor touches a cold surface, sudden condensation will take place. Sudden condensation will take place. Therefore, the brightness will reduce. Right. Okay. Essay question. Optics. Right. Angular magnification of telescope is given by alpha dash or alpha. So all of you all know. Angle subtended on the eye by the image divided by angle subtended on the unaided eye by the object. Alpha. With a suitable diagram show that the highest angular magnification will produce larger images on the eye. So this is your eye. So you can show here by drawing ray diagrams. Smaller the angle, smaller the size of the image. Larger the angle, larger the size of the image. On the retina. So what can you say there? Angular magnification takes place. So you can also represent it like this. There you go. Here you take object. Angle made here will give a size. A much more large image through the eye will make a larger image. Here I2, here I1. Larger the angle subtended, larger the size of the image. Smaller the angle subtended, smaller the size of the image. Right there. From the above diagrams we can show that. Larger the angle subtended on the eye, larger the size of the image. And smaller the angle subtended on the eye, smaller the size of the image. Right. Use the ray diagram drawn in Roman 1. Now you must draw this up. Use the ray diagram drawn in Roman 1. Which means you must draw the ray diagram. Sorry. Which means you must draw the ray diagram. Right, I'll draw it for you. Right. I'll draw the ray diagram here. Okay, now? Here you go. Objective, focal length, larger focal length. Here it's going to be f naught. Here it's going to be f naught. Okay, no? Here it's going to be f naught. So light rays coming from infinity, light rays coming from infinity will converge on the focal plane. Will converge on the focal plane. There you go. Here you have the eyepiece. So light rays coming here, light rays coming there. Here focal length of eyepiece. This distance, let's say that distance A. Right. Remember, you must draw only how these two rays behave. So, image formed here. Image of the object is object for the eyepiece. Right. Final image at infinity. These also should be parallel to that. Here you go. These should enter the eye. These should enter the eye. There you go. Right. What are they asking you? What are they asking you? Angular magnification. Here, angle subtended by the object on the unaided eye, alpha. Angle subtended by the image on the eye, alpha dash. So here, tan alpha is equal to opposite to adjacent. Tan alpha dash is equal to opposite to adjacent. Alpha alpha dash very small. Alpha alpha dash very small. Tan alpha is approximately alpha h over f naught. Tan alpha dash is approximately alpha dash h over f e. Angular magnification is f naught divided. We will erase this and use the definition. Alpha dash over alpha. Alpha dash is h over f e divided by h over f naught. F naught divided by f e. There you go. This should be drawn. This should be drawn. Very important. Please name it. Objective eyepiece. Objective eyepiece. Right. So Roman 1, this is the diagram. Roman 1, this is the diagram, that's the proof. Diagram and proof. Right. Calculate the angular magnification from the telescope. So now we know m is equal to f naught of fe. Have they given you the telescope? The 105. Yes. Substitute 100 divided by 5, magnification is 20. 100 divided by 5, magnification is 20. Right. Okay. Roman 3. The telescope is used to observe the moon. Infinity. Its eyepieces adjust to form the final image at the near point of the eye. Alternate adjustment. Don't forget alternate adjustment. Alternate adjustment. The moon subtends an angle 0.25 degrees on the unaided eye. Alpha is given 0.25 degrees. You can assume that the near point of the eye is 25 centimeter. Distance between the eye and the eyepiece is negligible. 1 degree is 0.08. Remember, this should be in radians. So 0.25 multiplied by 0.018. This together only is giving you radians. Alpha. Right. First, you must draw. Since you are drawing, going back. Here you must draw again. Roman 3. Light rays come from infinity. Will converge on the focal plane. There you go. This is f naught. Here image will form. Image of the objective is object for the eyepiece. Image for the objective is object for the eyepiece, right? Final image form at least distance of distinction. So these are a bit closer. Focal length of eyepiece is somewhere here. Right. Let me draw. Parallel goes to the focal. Please use the ruler when you are doing this. Here you go, image. Final image of eyepiece. So we need to give another color for this. Is this clear? That looks clear. Oh yes. Okay. Image for the eyepiece. Image of the object is object for the eyepiece. Right. Rest of the story you must consider these rays. These rays also meet here. Eye is here. Light ray is going to the eye. Right. You must prove this, Angle alpha. Here alpha. Angle subtended by the image on the eye. here h, here h dash. This distance is least distance of distinction D. Right. Tan alpha. Tan alpha is opposite to adjacent. Tan alpha dash, opposite to adjacent, h over ue. I can take this distance ue. Or we can say h dash divided by d. Alpha alpha dash very small. Alpha alpha dash very small. Tan alpha approximately alpha h over f naught. Tan alpha dash approximately alpha dash. I'll just take this h dash over d. Angular magnification is alpha dash. Angular magnification is alpha dash divided by alpha. H dash divided by d over h over f naught. Here h dash divided by h is f naught divided by d. What is h dash divided by h? Image height over object height. Linear magnification of IP is f naught over d. Angular magnification. Simplify the linear magnification. 1 over v minus 1 over u equals 1 over f for the IPs. UE d minus fe. Multiply by d, linear magnification. D divided by d, d over ue minus d over fe. Image distance over object distance, linear magnification, d over fe. ME is 1 plus d over fe. Now simplify this. Angular magnification is ME, if I go back, f naught over d. Now I can substitute here 1 plus d over fe, f naught over d. If you want, famously take fe out, put d in. 1 over d fe over d f naught over fe. F naught over fe. 5 divided by 25 plus 1. 100 divided by 5. 1 over 5 is 0.2. 1.2 times 20. Magnification is 24. Magnification is 24. What are they asking? Right. So angular magnification is alpha dash over alpha. Magnification is 24. Angle subtended by the image of the moon on the eye. That's alpha dash. Alpha, we already know from here. Alpha is 0.25 multiplied by 0.018 radian. 0.018 radian. Now you can simplify this. Here 0.25 into 0.018 radian. Alpha dash is equal to 6 multiplied by 0.018 radian. Because I am substituting only radian, I can't do this in degrees. You must convert to radians and do, then finally you can write in degrees. 6 degrees. Angle subtended by the image on the eye is 6 degrees. See whether you got the answer. Six degrees. Remember, every single term that you have taken here, you must define. H is image height of objective lens, height from objective lens, h dash, image height from eyepiece, UE, object distance for eyepiece, capital D, least distance of distinct vision. All new terms you have to prove it, at least once write it. So here image is formed, ME F naught over D, apply for the eyepiece, get ME, do the substitution, rearrange it slightly or substitute it here itself. Magnification 24. Magnification 24 means alpha dash over alpha. Alpha is given 0.25 degrees, 0.018 cross multiply, 6 degrees there, alpha dash is 6 degrees. Here, alpha dash is 6 degrees. Right. Okay, no? Alpha dash is 6 degrees. Once you need it, I'll just go back. Write down. This is Roman number 3. Okay. Right now. Okay. So this part I have done now. This part done. The objective of the telescope in the above adjustment has to be moved by 10 centimeter in order to focus on an object at a closer distance. Find the distance to the object from the objective of the telescope. The objective of the telescope in the above adjustment has to be moved by 10 centimeter. So if you are looking far away, you must go behind. If you are looking closer, you must go where? Forward. It's a very basic observation. Yeah, very basic observation. Right? So now, best is go back. Go back. Go back to the diagram. Now, what is the distance here? What is the distance here? Okay. So what are they telling you? To view the object closer, the above adjustment means when the final image is formed at the least distance of distinct vision. Objective should be moved by 10 centimeter. Right. So from this position to look closer, I must go closer. 10 centimeter here. Eyepiece has not changed. What is UE? What is UE? UE we have not found, but you can find UE if you want. Here you go. 1 over V minus 1 over UE equals 1 over focal length here. 25 1 over UE minus 5. 1 over UE is 1 over 25 plus 1 over 5. Common denominator 25, 1 plus 5. UE is equal to 25 divided by 6 centimeters. That is 4.16 or 17 centimeters UE. Right. So if I go back, this is 4.17, this is 100. 100, 4.17. Right. 100, 4.17. This I move some more 10 centimeter closer. Some more 10 centimeter closer. So if I move 10 centimeter closer, I draw it here. It's easier. 10 centimeter closer means IP's location has not changed. IP's location has not changed. That means image will form at the same location. That means image will form at the same location. So what is your image distance? What is your image distance? Image distance for the objective is 110 centimeters. Right? Here UE, final image is formed at least distance of distinction, same location. So here I am moving this closer. The question is, where is the object? Where is the object? Understood? So to see close objects, I move objective closer. To see distant object, I move the objective away. So closer to object, away from object. Okay? So I think now we can see. Final image is formed at this distance means UE won't change. So I bring this closer means now the image distance is 110 centimeters. Now let's go back. Let's go back. Here. For the objective. 1/v minus 1/u equals 1/f. Object distance we don't know, focal length is minus 100. Image is minus 110. By 100 plus 10, 110. 1/u is equal to 1/100 minus 1/110. 110 minus 100 divided by 110 times 100. Turn upside down, 110 into 100 divided by 10. 1100 centimeters. Object is kept at 1100 centimeters. Yeah. So remember this, the Roman number 4. I have shown the diagram there. Show the diagram here. Here you go. To see close objects, objective lens is moved closer. Move closer. Now the image from the objective is object for the eyepiece. That's your image distance. Image distance 110. Image distance 110 means you can find the object distance. Okay. Image distance 110 means you can find the object distance. Right. So good essay question. Hopefully you learn from it. Is it clear? Hopefully you learn from it. And there you go. Your final relationship. Final relationship. Right? Right. Okay. So what have we done today? 20 MCQs, one structured essay, one essay. Altogether how much? Altogether 220 MCQs. 220 MCQs. 11 structured essay, 11 essays. Is that progress? This is 100% progress. Okay. This is 100% progress. Therefore, remember, think positively, you're moving forward. Since you're moving forward, confidently keep going forward. Same intensity, keep on working. Remember, your objective is to make sure that you do this exam very well. In the very first try itself, you're going to get what? A very good result. Is it clear? Be confident, keep on working. See you tomorrow. Good night.